Okay, once again, you're welcome to today's online remote Cisco instructor training class for CCNA2 or routing and switching as well as wireless enterprise network. Now, in today's module, we are going to be basically looking at the initial switch configuration when we're dealing with switches, because that's the center of our class, routers and switches. So when we're dealing with switches, we want to look at how we can do basic configuration of these switches. And then we also want to look at how we can configure switch ports. Every switch port is important, so we want to look at how we can configure them. We also want to look at how we can secure our switches, especially for remote access. We're also going to be looking at basic router configuration, and then we'll also verify directly connected networks. So we're going to go straight. Now, basically, a switch is a layer 2 device. Now, we have what we call layer 2 switches and we have what we call layer 3 switches. Now, for those of you who are just new to Cisco, probably you have not taken the CCNA1. In the introduction to network, you will understand that every network has certain components. It has the end devices. The end devices are the devices that actually generate the traffic or are the endpoint of our traffic. Then we have the intermediary devices. The intermediary devices are the devices that our traffic comes into for decision making. So the intermediary devices actually works on our traffic to determine the flow pattern or to determine the destination or to determine how to forward this particular traffic, sorry. And then we also have what we call the network media. That is the medium at which the end devices interconnects with the intermediary devices. Now, for CCNA2, or when we come to talk about switches and routers are basically intermediary devices. When we say intermediary devices, we're saying that they are not the original source of the traffic or the PDU that is being forwarded or is being monitored. Okay, so they are not the original source, but they play a very key role, especially when it comes to moving this particular traffic from one point to the other. Okay, so that is where the switch comes into place. So in introduction to network also, you must have been thought of what we call the OSI model. The OSI model basically is a reference model that explains what happens with your PDU or with your data from the point at which the data is generated to where it gets to its destination. So in the OSI model, we are told that we have different layers. And this is just a summary for those of us who have taken the course. So we have 7 layers. We have the physical layer. We have the data link layer. We have the network layer. We have the transport layer. We also have the presentation layer. We have the session layer. We have the application layer. And in each of these layers, they have their roles and responsibilities. They have the functions that they carry out on each of these layers. And so, especially in CCNA2, where we talk about routers and switches, we are going to be centering basically on the data link layer and the network layer. Now, the data link layer focuses more on the switching devices. So the switch device is the device that functions mostly at the data link layer. Now, the router functions basically at the network layer or the layer 3 of the OSI model. And so the router basically does routing and routing processes or path determination processes, and then packet forwarding. Now, but the switch actually does a lot of switching activities. All right, and so in switches, there are switches that perform certain type of layer 3 services. So we call them layer 3 switches. So where across this topic, you will come to discover that there are times we'll make reference of a layer 3 switch or a layer 2 switch. But one thing is for sure, they are all switches. They are all switches. So when that time comes, we will explain what happens. Now, how does a switch or a router boots up? How does it behave? First things first, most of them are like they are like computers. Okay, the switches and the routers are like computers. And the computer has the hard drive, it has the operating system, it has the motherboard, it has the processor, it has the RAM, it has, all, and the operating system, it has all those components that makes it a computer, both hardware and software. Now, in the case of a router and a switch, it also has something similar. It has the motherboard, like the system. It has the processor, like the computer. It has the operating system. Now, in this particular case, ours is not just the operating system. It's called the inter-network operating system. That's why it's basically called the iOS. That's why it's basically called the iOS. So, as the iOS, we believe that it has certain commands, or it is designed or structured in a way it can be able to enable intercommunication between devices, intermediary devices, as well as between end devices, or between end devices and intermediary devices. Now, how does this device boot? Okay, how does it boot? So, like how our computer boots on a normal day, you power on your computer. What happens? Your operating system is located in your hard drive for your computer. And so the booting basically for a computer is a process of loading your operating system from hard drive to where? To your RAM. And so in this particular case, the iOS is located in a particular storage device. We are going to be looking at that very soon. And it also has a RAM. That is where all these processing activities takes place. So the interesting part about these intermediary devices, both routers and switches, is that when it comes to the issue of booting, sometimes they have multiple boot environments. For instance, in our normal computers, you can decide to tell your computer to boot from your hard drive. You can decide to tell your computer to boot from your CD-ROM. You can also decide to tell your computer to boot from the network. Okay, you can decide to specify anywhere you want your computer to boot from. So it is the same thing. So step one says, first, the switch loads on power on self-test. Now, what is this power on self-test? Now, in your motherboard or in your device, it has some basic instructions, what we call booting instructions or booting sequence. All right, these particular instructions actually are there to ensure that the booting process goes on very, very well. Now, one of the process is to verify the availability and functionality of all the hardware components that are essential as regards this booting process. For instance, the RAM is very essential to the booting process. So when you start your switch, what it does is that the post-process tests whether the RAM is available. If the RAM is available, is it in good condition? That is one of the things it does. It checks the hard drive. Now, in case of the switch, we don't call it hard drive, we call it NVRAM. It has what we call the RAM. It has what we call the NVRAM. The NVRAM stands for non-volatile RAM, non-volatile read-only memory. Okay, so it has the NVRAM, it has the RAM, and it also has the BIOS, where it contains this basic information as regards the post-process. So it's going to check whether the CPU is available, whether the CPU is steady, whether the CPU is in good order. It's also going to check for the flash. The flash is the location where the iOS is usually stored. So if I have an iOS on my switch, I must be able to make sure that my iOS is in the flash, because that is one of the locations that the switch is going to check or verify the iOS. So the post process will verify the availability of your RAM and functionality, of your flash and functionality, and of the motherboard and functionality, and every other device, and as well as the CPU. Okay. Once it checks that, the next thing is that the switch loads the bootloader software. All right. The bootloader is basically a small program that is stored inside the ROM. The ROM stands for read-only memory. It's a non-volatile device that actually has some pre-installed information as regards the boot instructions of the computer. Okay, so basically the ROM is actually there to execute all this information. Okay, all the information that are there. So it is important that we know the role of the ROM. The ROM is very, very important. It's very small actually, but as soon as your computer starts, what it begins to do is it begins to execute the set of instructions that are in it that have already been programmed. So you see, step one is to check and verify the availability of all these hardware devices that are essential to the boot. The step two is now to begin to execute these instructions that are already in the read-only memory, which is the ROM. Step three, the bootloader performs low-level CPU initialization, which means that it initializes the CPU registers, which controls where the physical memory is mapped, the quantity of memory, and its speed. So you see, all these things are processes that enhances the smooth booting or the smooth loading of the iOS into the RAM. So the CPU actually has its utilization instruction, and so the bootloader begins to perform this particular services. Then step four, the bootloader initializes the flash file system on the system board. Okay, then finally in step five, the bootloader locates and loads a default iOS operating system software image into the memory and gives control of the switch over the iOS. What are we saying here basically? What we are saying here is that the booting process is just a process which you load your iOS from your flash into your RAM, so that you, the instructor, or you, the end user, can be able to manipulate this particular device, or this particular router, or this particular switch into what you basically want to use and perform. Okay, so the switch attempts basically to boot using information in its environment. So sometimes you can decide to change how this particular information is stored or how this information is executed. But the iOS operating system initializes the interfaces using the Cisco command found in the startup configuration file. Now, somebody might ask, what is a startup config file? All right, or probably you have had a running configuration file. Okay, or running configuration. Now, you see, when you load your switch or your router, there are two configuration files. There's what we call the running configuration file, and there is also what we call the startup configuration file. Now, what's the difference? The startup configuration file is the configuration that has been stored on that device, that is kept in the NVRAM, the non-volatile RAM. So if I begin to configure my switch, if I begin to configure my router, the content of my configuration is going to be stored in a file located in the envelope. Okay, but the running configuration is the actual configuration that is being executed in the RAM as at that particular moment. So as at the point at which the switch or the router is running, the commands that are being executed by the processor at that moment over the RAM is the running configuration. So most of the times we need to know that the booting sequence has a stage at which it also loads the startup configuration file. All right? So the startup config file is called the config.txt and is also located in Flash. In the example, the boot environment variables is set using the boot system global configuration mode command. And we notice that the iOS is located in a distinct folder and the folder path is specified. So if I want to know the location where my iOS is located, I just use the command show boot. Okay. Once I use the command show boot, it's going to now bring me the file system. So as you see here, this is the output of a particular switch configuration. And number one is telling me that this is on switch 1. And as it is on switch 1, I am in the global configuration mode. I'm in the global configuration mode. And then this is the location of my flash, my flash as in my iOS. All right. And it's telling me the model of the switch. This is the model of the switch, C2960 switch. Okay. So we're going to discuss a little bit about this very soon. Okay. So here, this boot system you see here is the main command. All right, boot system flash, meaning that I am telling the switch to boot the system, to boot that device from the flash, and the directory and the path of the flash is located here. This is the path in which it is located. Okay, and then basically that is it. This is the flash, the iOS. This is the iOS here, and this is the location that we have here. Now, those of you who have seen switches before or have played around with switches, this is just an example of what it looks like by one of the panels by the left-hand side. You have some LED points here, like LED points here, and something you see something SIST or RPS or STAT or duplex or speed or PoE. Now, what are all these things? These are just LED information that will give you about the system as the system is coming on. So, for instance, it says when green indicates on this start here means status. All right, this status here. All right, and we said when green indicates on the status port, it means the status mode is selected, which is the default. Okay, port status can then be understood by the light associated with each. Okay, then when we come to system here, the system shows whether the system is receiving power and functioning properly. That is when you see this LED light here. All right. How about this RPS? It just means redundant power supply. Some switches do have it, some switches do not. What does it mean? You have a switch that has a power supply, and then it has like two different power source. All right. So like redundancy. So and once this is there, it means that it shows you that the redundancy is actually there. And then duplex here indicates that the port is in duplex mode. Now, when we say duplex, we're trying to say the flow pattern, of the traffic. You know, we have half duplex, we have full duplex. So this just to explain to us the flow pattern. and then the speed. When green indicates port speed mode is selected. All right. So on your switch, by mere looking at this, you already know the situation that you have. Now, for instance, we have some lights. Some will be green, some will be blinking green, some will be amber, some will be blinking amber. And what does it mean? What does it mean? Because if I have lights here, some are green, some are amber, some are blinking green, some are blinking amber. I mean, what does it mean basically? And that's what this page is telling us, the indicators. Okay, so if I am on my POE, for instance, if there's no light, it means that POE is not selected here. All right, POE is not selected or is not applicable. But if under status I see green, it means that the link is up. And if it's blinking, I mean, it means that there is activity. That means the switch is processing. There's traffic passing through. Okay, but once I see amber on my switch port, it either means that it's green. Sorry, it's blocked. All right, either the port is blocked or maybe there is a loop. You know, there is a loop somewhere. Now, when we say loop, we're trying to say a particular traffic keeps going round and round and round and round and endlessly. So in order to prevent this going round and round, endless movement like this, the switch has a protocol like spanning tree. We'll talk about that later. It has a protocol or a program that helps you to just block one of the ports to prevent this persistent moving round and round and round of the switch. All right. Okay, so how do we recover from a system crash? First, you connect your PC by console cable. You say, what is a console cable? I think I have one here. I don't know whether you see it well. This is my console cable, and yeah, this is my console cable. Just a minute, let me get a switch. Excuse me, a minute. All right. Now, here with me is an example of a switch, a Cisco switch, and the description of the ports I am making is, you can see it. I don't know whether you can see it very clearly, but that's basically what you see. Now, the switch has ports. These are the ports of the switch that we've been talking about. Now, but behind the switch, some switches have it in front, some have it behind. But this this is a Catalyst 2960 series, switch. So the console port is behind. It's behind, and you'll see it's written console there. Now, what happens is that if you want to connect your switch to your console port, first of all, your cable to your console port, you carry your console cable. It has the edge of an RJ45, and then I connect it here. Once I connect it here, I'm connected to the switch. Then I come to the end. In this case, I had to connect a USB adapter so that I can be able to connect it to my system. So I'll use this USB port to connect to my system, the USB port of my system. All right. So step one is you connect your PC using a console cable. to get a terminal emulation software. Now, what then is a terminal emulation software? Okay, I have one. You can have hyperterminal, or you can have TerraTerm. Let me power on the switch, then I will load on the environment so that we will see it together. First of all, where's my hyperterm? TerraTerm. Okay, I have my TerraTerm here. All right, so let me share it so that you also see what I'm talking about. Where's my TerraTerm? Okay, so I'm sure you can see it. Let me power on the switch, then we will now do. Now, usually you come to serial here, and you see under serial, I am going to use here that says USB to serial COM port. So I'm going to select that and click OK. Now, there's nothing there, which means that I have not powered on the switch. So I'm going to now get a power, and then I will power on the switch. So just a moment. Okay, so I'm going to power on my switch. All right, so I've powered it. So now you take note, you'll see some lightning, and you see the light is blinking. All right, now look at the TerraTerm. You see that the switch is initializing. Can you see it here? You see that the switch is booting now. Okay. And this you can see that simply because I'm connecting to the console cable, to the console ports of the switch. All right. Now, how do we recover from a crash? For instance, your system has crashed or you have a password problem. We'll get to that in details. But first thing here, we said connect your PC to the console port of which we have connected, launch in your terminal emulator, which we have launched in our terminal emulator now. Unplug the switch port power cord, okay? Unplug the switch port power cord and then reconnect the power cord to the switch, and within 15 seconds, press and hold down the mode button while the LED is still flashing on. Where is the mode button? Okay, you can see here, I have a mode button, is here. This is my mode button. It's one small button there. I don't know whether you can see it well, but that's the mode button. And I've not yet done that. I want to just load the switch so that you just see the process. Then we'll do how you can recover it from a crash. So if you press, it says press the mode button until the system LED turns briefly amber and then solid green. Then release the mode button. Okay. Then step 5, the bootloader switch prompts appears in the terminal emulation software on the PC. The bootloader command line supports the command to format the flash file system, reinstall the operating system software, and recover the lost forgotten password, for example. So what we are saying here, these steps are assuming I've forgotten my password, or assuming my iOS is crashed and I want to reinstall it. These are the steps. We'll find time during our lab sessions. During our lab session, we'll find time and then we'll do it. Okay. So my switch Let me see. All right. It says, would you like to enter the initial configuration dialog? If you say yes, it means that you're going to do the configuration of the switch from scratch, afresh, okay? But I will say no, all right? So that it means that there are some configurations, then you do. So you see already it's bringing me here. Let me increase the font size and let's see. Increase the font size. Let's try 14. Okay. All right. So if I have this now on my switch, so you see I'm in my switch. So basically I can begin basic configuration, but we will get to the basic configuration very soon. Okay. So how do you enter the switch? That is just what I've explained to you. I have my PC here. I have my switch here. I use the console cable. Okay. And then this is a router. Once we come to walk about router, I'll talk about it. This is a router. So I have my switch, my PC, my switch. Then I use my console cable to enter. To manage switch from a remote network, the switch must be configured with a default gateway. Now, what does it mean to manage a switch from a remote location? Assuming this switch is here and I am in another location, but not physically close to this switch, and I want to remotely gain access into this switch. All right, I want to gain access to this environment. I want to gain access to the switch. Now, instead of me to use console cable, in this case, instead of using console cable, I will use I'll use a virtual interface or logical method or so, and that is what we're talking about here. It says in the figure, the switch virtual interface on switch 1 should be assigned an IP address. The switch virtual interface is a virtual interface, not a physical port on the switch. A Cisco cable is used to connect to a PC that the switch can be initially configured. So after that, I can just remotely log into the switch and manage the switch using the IP address. So, and they're saying that I need to configure a default gateway. Now, let's see what is in this switch. For instance, if I do show, okay, let me enable, then show run, for instance. Now, I want to check the virtual interface, the default gateway, and see whether we have configured anything. And from what we can see here, this switch is blank, clean as a slate. There is no configuration. Everything is just in its default state. But there is something interesting here. Look at this. Look at it. Line VTY and then line console. Okay, the console now is these two are ways you can gain access into this switch to be able to manage it. Whereas one is physical, that is the way I have just gained inside this particular device. Okay, and then this is logical. VTY is virtual terminal lines. Okay, virtual terminal lines. So I can configure this switch to be able to manage it remotely without physically coming in here. All right. So configure the management interface from VLAN interface mode. An IP address and a subnet mask is applied to the management SVI of the switch. Okay, so you have to give it an IP address. All these activities, we are going to do it as part of our lab. Okay, so I'm not going to do so much time. When we get there, we're going to do it. So this is just the example of how to go about it. You enter the global configuration mode of the switch. If you enter the global configuration mode, then you go to the default VLAN, or not the default, sorry, the management VLAN. The default management VLAN is VLAN 1. Okay, The default management VLAN is VLAN 1, but you can change it to 99, or you can change it to anything you want to change it to. Okay, that one is there. And then just go to the management VLAN, then you assign an IP address to that management VLAN. All right, whether this is an IP version 4 or an IP version 6, of which you're all familiar with it by now. Then issue the no shutdown, then you end. After that, you save your configuration. Copy running config space startup config. What does it mean? Copy the content that is currently running in the RAM now and save it in the file that is saved in the NVRAM. That's the startup config. And this so that whenever you reboot your system, your device, you can gain access to it. So when we come to do our lab, we'll practicalize this. So once you do that, then configure the default gateway. The switch should be configured with a default gateway if it will be managed remotely from networks that are not directly connected. So because it will receive default gateway information from router advertisements. All right. And how do you do that? You still go to your global configuration mode, then IP default gateway, then you assign this particular. So remember, this IP address is basically so that you can be able to reach out to this particular switch. Okay, you can reach out to the particular switch, and then you verify your configuration. Once you use show IP interface brief command, it gives you the IP address of all that is in the switch, and then show IPv6 interface brief. So now in our own case, if I come here and I say show IP interface brief, and I do like this, you see, unassigned, 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 blah, 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 blah. No IP address, okay? Because I've not assigned any. And the management VLAN, I only have VLAN 1, which is the default VLAN, because this switch is basically clean, new. So, and this is up. So this is what we have here. This is what we have here. All right. So we have our first lab. In this lab, you will complete the following objectives. Part 1, cable the network and verify the default switch configuration. All right, we have done that. I have cabled the network and we verify the basic default switch configuration. Part 2, configure basic network device settings. So we're going to find out what are the basic things that we need to do. When we say configure the basic device settings, what basically are we talking about? We're going to do that. Then part 3, test, verify and test network connectivity. Then manage the MAC address table. Okay, all right. So we have a lab, and what we're going to do now, some of us have, packet tracer. If you don't have, you can download it. So packet tracer, let me launch my own. Make sure you download the latest one. All right, so I have my packet tracer, so let me run it, the latest one, or let me just show you how to download it. Since you are instructors, maybe your students would want to download it. So let me show you how to download. You log in into your profile. Let me log in into mine. Oh, sorry, let me share my browser so that you can see what I'm talking about. Okay, all right, so this is my profile. Log into your profile, and then you go to your class. So let me launch the class, this particular class. So as instructors, you have instructor resources, okay, or instructor materials. The PowerPoint for this class, you can get it. The packet tracer, you can get it. Tutorials, you can get it there. You can get quite a lot of other things. So this is the class. All right. So here they say instructor home. Instructor home. The down left. So I click instructor home. Now you see instructor resources. I think we talked about this in our first class. So instructor resources is what we have here. So all right, let me check. So you can have student resources, instructor resources. So you pick the language you are very conversant with. Let me see. Okay, these are most of the resources you get. But for packet tracer, let me come back just a minute. Where packet tracer, packet tracer, packet tracer. Where's packet tracer? Search packet tracer. Okay, introduction to packet. No, not the course. Looking for the application. Okay, resources. Look at it here. So look at packet tracer resources. Okay, so here packet tracer packet download page. So you can just come in here. So you're going to download the latest version. You pick your version. My system is 64-bit. If yours is 32, you pick 32. If you're using Linux, you pick Linux. If you're using a Mac, you pick the version. If you want to run it on your mobile application, so you pick the one that suits your system. So I'm using Windows. So I'll click here and then 146 MB download. All right. So my download is in progress. So let's see. Let's just wait for a moment. Downloading. All right. So the packet tracer basically is an application, a simulator, a network simulator that you will need in order to carry out this online virtual class. Assuming we are in a physical class, we would have to be using real physical equipment, routers and switches and things like that. But for those of you who have access to those devices, I encourage you to go ahead. But if you don't have, the packet tracer you are downloading is as equally important as the live devices, is as real as whatever you see live. Okay. Plus the fact that with the packet tracer, you are able to simulate a complete network. You can have multiple routers, multiple switches. You can have your connectors, connect them. You can do everything, almost everything you can do with the physical device, you can do with your packet tracer. So I know some of you might have had the versions, but it's good to have the updated version so that you can be able to benefit from all the resources that you have there. All right. So while this is going on, let's go back to our class. This is our class. This is our class. We are in module. Okay. Sorry, we are on the first module. Where is it? Oh, what are we going? Modules. Oh, sorry. We're supposed to launch the course, not do exams, tests. Okay. All right, so our download is now complete. Okay, so our download is complete. So I'm going to just go to my download file, programs, and then I'll just execute it. So I've downloaded version 7.3.0. Okay, packet is 7.3.0, and that is what we are going to be using for this class. So if you have, that's great, but if you don't have, I'm going through the installation process with you so that we'll um, all move together. All right, so installing, next, install. Very, very easy to install. Okay. All right, so my installation is going on. Basically, what we just want to do, we want to do the basic configuration of a switch. So let's go to the lab, and we're going to see basically how we can do that. Just a second, there's something I'm looking for so that it will make it easy for us. Let's see. Okay, installation. Okay, the existing file is marked as read only. Click to read. Oh, okay. I think I'm having some issues installing it. Okay, I'll sort out the installation later. All right, but for the purpose of this class, let's quickly do the basic configurations that we want to do. First of all, we connect our cable. We have done that basic configuration. So the next thing I'm going to do is, how do you name your switch? Okay, you see, by my device default is called switch here. All right, what is called switch here? So I'm going to name it. I'm going to change it. Now, all the configurations that you intend to do on your switch or your router, you have to do them on your global configuration mode so that you will be good. So I'm going to get there. I will type in configure terminal. You can always tap it. Sorry, I'll do enable first to enter my privilege mode, then configure terminal. All right, so I'm in the global configuration mode. So I'm going to change the name. So maybe I will call it what do I call it now? Let me call it so I'll say host name. That's the command, host name. Then let's say CCNA2. Once I press enter, you see that the name has changed. Okay, host name CCNA2. Then after changing the host name, I can decide to do the next thing, which is secure my router. Now there are two ways I can do: enable secret, enable password, sorry. Now if I do enable password, and then I type maybe Cisco as my password, you see, this is my password. But if somebody gain access to my router and then comes and do, let's say, show running configuration, you will see my enabled password. You see my password is in clear text. Okay, so what is advisable is, if you use clear text like this, then what you need to do next is to do service password encryption. All right, so let me see here. Then you say service password encryption. That encrypts the password. So if I say show run, you see the same password that you see it is being encrypted. All right, so that way to do. Another way to do, instead of just doing that, you can just say enable secrets. Enable secrets, then maybe let me call it class. All right, now I have created my password. Then I need to also secure my virtual terminal lines. I need to secure my console lines, so that anytime I'm logging into the router, I can use them. So I can now say line console 0. Then I'll say password. Let's say Cisco. Okay. Then line VTY. We saw our own 5 to 15. Password is what? Let's say Cisco,
Class.
for instance, or we can say class, or whatever it is we want to use Cisco. All right. Then what else? Okay. Login. Then exit. Okay. Then service password encryption. Now I've encrypted my password. So in my basic setup, the first thing I did was change the name of the device. The second thing I did is to secure the device. Just some basic security. And one way is to secure your console cable, console port, secure your virtual terminal ports, and then secure your privilege mode. Okay. So for instance, now if I exit, and I want to log into the router. Now I press enter, enable. You see, it's asking me of what? Password. All right, it's asking me of password. I think we use Cisco, right? Okay, no, class. Good. So you see, I've entered because we have put in your password. Then another thing to do is part of the basic default basic configuration is to set up your SVI, your switch virtual interface, where you can be able to log into this device remotely. All right. And there are two things to do when it comes to that. First, we said you will have to configure a VLAN as your management VLAN, and then you now give it an IP address. Then you will also have to do the IP default gateway command. All right. So if I come here and I say show VLAN, all right, what are the VLANs that I have here? I only have one VLAN 1, and these are all the ports on my switch, and they are all attached to that VLAN 1. All right, so when we get to creation of VLANs, we're going to do that. So for instance, let me just set VLAN 1 as my default VLAN. So I can now say configure terminal, then IP default gateway. Then I'll give an IP address. But first of all, let me say interface VLAN 1 IP address. Let's say maybe 192.168. Let's say 1.1 with a subnet mask of 255.255.255.0. All right. So once I enter, no shot. So I have assigned this IP address. So how about the particular switch? So I can say, let me exit IP default gateway. Let's say 192.168.1. Let me say .2. So you see, I have given this system an IP address 1.2. This particular switch. So if I want to gain access into this switch remotely without using my console cable, maybe using POTI or any application, remote application, and then I would have to use this particular IP address in order to gain access. I think these are like some of the basic configurations. I don't know whether there is any other one. In the meantime, remember I have set up an application for us. I've set up, what do we call it? WebEx Teams. This is the WebEx Teams. And I would want us to chat when you have issues or when you have observations as regards today's class, or maybe questions. We can discuss here, and then I'll let you know. Now, the assignment for us today, I want everybody to create his own network using Packet Tracer. Let me launch my Packet Tracer, the one that I had. I wanted to update it, but unfortunately, it's not updated. So let me launch my Packet Tracer. Okay. Okay. Oh, still having issues. So you are to launch your Packet Tracer and then do your basic configuration on your switch. Okay, do your basic configuration on your switch. The next class we are going to have is going to be on Thursday, and we might have to do a little more of the practicals that we have. I had to stop here for the labs so that we do not have so much to do. Okay. Now, configure switch ports. Okay, configure switch ports. Now, what are these switch ports? Full duplex communication increases bandwidth efficiency by allowing both ends of a connection to transmit and receive data simultaneously. This is known as bidirectional communication, and it requires micro-segmentation. All right. So a micro-segmented LAN is created when a switch port has only one device connected and is operating in full duplex mode. Full duplex mode means that you can transmit and you can receive at the same time. You can transmit and receive at the same time. So unlike full duplex communication, half duplex communication is unidirectional. All right. So half duplex, you can transmit, then you can receive afterwards. But in full duplex, you can transmit and receive both at the same time. Okay. So gigabit Ethernet and 10 gigabit network interface cards require full duplex connections to operate. So in full duplex mode, the collision detection circuit on the network interface card is disabled. So full duplex offers 100% efficiency in both directions, both transmitting and what? And receiving. And this results in a doubling of the potential use of the stated bandwidth. Okay, so I think all networks should be full duplex now, unless maybe you want to set up your network to meet a particular requirement. Okay, now how do you configure switch ports at the physical layer? Remember, I said in the OSI model, physical layer is the first layer, then data link, and so on and so forth. So switch ports can be manually configured with specific duplex and speed settings. So you can decide the speed that you want to set up on your network. So the default settings for both duplex and speed for switch ports on Cisco 2960 and 3560 switches is automatically, meaning that if I pick this cable here is a Cat6 cable. So Cat6 cable is a gigabit cable. So if I plugged it on this particular switch, it will assume the full capacity of this cable by default. If this switch is a gigabit switch, it can take, so it will just assume 1000 Mbps. So here I have there's another cable I have here. Green, this cable here. This cable here is Cat5 cable. All right, it's a Cat5 cable, and Cat5 can give me about 100 Mbps. So if I pick this particular cable and I plug it into the same switch, on the same port, I am going to assume 100 Mbps. So that's what the point is saying, that we can actually have this particular capability to move simultaneously. All right. So how do we configure the port? Assuming I want to configure this port to not to be automatically. I want it to just run on 100 Mbps or maybe 1000 Mbps or whatever it is I want to run. It's very simple. I will go to my switch, I go to configure terminal, then I pick in the particular port I am using. If it is fast Ethernet 01, then I will say interface fast Ethernet 0/1, then full duplex full, or speed 100, and then end. Let me show you what I mean. So for instance, this is my switch. All right. So, oh, sorry. A switch. Let me do so that you can see. So I'm in the switch, I'm in the configuration mode. Then I should pick a particular interface. How do I know the interfaces that are here? So if I say show IP, sorry, let me exit. Show IP interface brief. So you see, these are the interfaces on this switch. So let me pick this first interface, for instance, fast Ethernet 0/1. So if I say interface, let me enter my global mode, configure terminal, then interface fast Ethernet 0/1. Bam. Once I enter, you see my prompt will change. My prompt will change from the normal config that is here to config-if. This is simply telling me that I am on an interface mode. So any configuration I start applying now is only going to apply to this interface. All right, any configuration I apply now is going to apply to this interface only. So if I say duplex, now there are times you are typing commands. If you want it to auto-complete, you just press your tab, it's going to complete for you. All right, I'm sure you did that in CCNA1, or you are having difficulty remembering the next command or what you want to put, you can just put a question mark. If you put a question mark, it's going to bring out the options for you, as you can see here. Oh, sorry, I thought I was sharing my terminal emulator. Okay, yeah, I'm sharing it. All right. Okay, so if I say duplex, I can make it auto. By default, the duplex is auto. Okay, so I can decide to make the duplex full. I can decide to make the duplex half. All right, so in this case, so if I say full, all right, if I say duplex full, then speed, then I can type the speed I want, or if I don't know what to type, I just press my question mark. So it means I can put it to 10 Mbps, I can put it to 100 Mbps, or I can leave it as auto. All right. So if I put 100 and I press enter, then end. After that, you save your work. So what it simply means is that this particular port, Ethernet 1 here, is just taking 100 Mbps and has been set to full. So, well, basically, that's how you can actually force it that way. Now, when automatic medium dependent interface crossover is enabled, the switch interface automatically detects the required cable type. Now, you see, in CCNA1, you were taught about cabling, network cabling. And in network cabling, you were taught about straight-through cables that are designed to interconnect unlike devices, for instance, a switch and a PC, and things like that, the router and a switch, and unlike devices. And then you were taught how to use crossover cables. Crossover cables where you use to connect like devices, probably like switch to switch, router to router, system to PC to PC, and things like that. Now, this auto MDIX simply means medium dependent interface crossover. what it means is that it doesn't matter the cable I use, whether it is straight through or crossover. Once I enable auto MDIX and I enable it on this particular device, what happens is that if I use a straight through cable to connect like devices instead of a crossover, the port will automatically adjust and change the settings to suit the crossover settings that was supposed to be there initially. And that is it. But if it is disabled, it simply means that I definitely have to get a crossover cable in order to connect maybe a switch and a switch. All right. So we are saying when connecting two switches without the auto MDIX feature, straight through cables must be used to connect to devices such as servers, workstations, routers, and then crossover cables must be used to connect to other devices such as switches or repeaters. All right. So I have a switch, I want to connect to another switch, I use a crossover. I have a router, I want to connect to another router, I use a crossover. I have two PCs I need to connect, I use crossover. That is when MDIX, auto MDIX is disabled. But once it is enabled, it will automatically sort it out. And so we are saying that by default, this switch 2960, this Cisco 2960 series and 3560 series, the auto MDIX feature is enabled by default. So if you have a switch that is not enabled by default, you would have to do that, and you would have to configure it yourselves. Okay. All right. So here are some few commands that maybe we can run by so that we can know master. The first one is show interfaces. So if I come to my router or my switch, and I say show interfaces, all right, I say show interfaces, all right, then I press enter. It will give me all the details about the interface. You see, there's a difference between show interface brief and show interfaces. Now, if I do show interface brief, I will have to put show IP interface brief, show IP interface brief. You see, it's just going to give me the interfaces and whether they are up or down or the IP addresses. Okay. But if I say show interfaces, it's going to give me way beyond that. You see, the VLAN one is an interface. It will tell me the line is up, protocol down. It will tell me the hardware type. It will tell me the IP address. It will give me the MAC address. It will give me the encapsulation set. It will give me almost everything. If I come to Fast Ethernet 01 here, as you can see, the interface is down, the protocol is down, it's not connected. Yeah, it will tell me the MAC address of that particular interface. It will tell me the maximum transmission unit. It will tell me the bandwidth capability. It will tell me the delay. It will tell me the reliability. It will tell me whether it's in full duplex. And it will tell me every details about this particular. So this command is very important when it comes to troubleshooting. And you do not understand the behavior of a particular link or a particular port, once you just say show interface, it will give you quite a lot of information you need about that. Okay. The next one is show startup config. Startup config is the details in your NVRAM, the information that has already been configured in your what do we call it, your NVRAM. All right. Remember, I said that we have your startup config and your running config. Your running config is what is currently running in your RAM. Your startup config is what is running on your NVRAM. So if you see all the commands I have been running on this particular switch that I have here, I have not saved it to my NVRAM, my startup config. So they are only running on my running configuration. So if I say show running configuration, so you see it will tell me my host name is CCNA2. It will tell me the password, enabled password. It will tell me the enabled secret, and can you see that? And then what else did we configure? We have configured Ethernet 1. Sorry. Okay. We have configured Ethernet 1. Where is it? Okay. Yeah, we have configured Ethernet 1. Look at it here, and it's full duplex. Okay. And then what else did we configure? We have configured VLAN 1 with this particular IP address. We have configured the default gateway IP, and we have configured passwords on our VT wire and our console lines. So this is our running configuration. Now, if I do show startup config, all right, now you will see the content should be different. What is it saying? Startup is not present because I have not even saved anything. I've not even saved anything. See, if I saved it, then you'll see. So that's what to see. All right. Then show flash. Show flash and show version has to do with your iOS, details on your iOS. If I say show flash, all right, now you see it will give me the directory, the location where my flash is, and it will tell me, can you see it here? This is it. It will tell me the flash that I have. If I say show version, it will give me the version of the iOS. Can you see the version of the iOS? Look at it here. I am running version 12.2 on this particular switch, 12.2. And this is my technical support. And then these are the details of my version and things like that. Then show history. Show history. If I run show history, it will give me all the commands that I have run or configured on this router. All right, so I have done enable, I have done show VLAN, I have done configuration terminal, I have done show IP interface brief, config tip, show interface. So these are the commands. So for instance, you want to know, this is usually used during investigations. All right, investigations or audits. You want to find out a particular person used the router. You want to find out the commands that was used, so you can do show history. All right, so you can do show IP interface. All right, we have done that for IP version 4 and 6. Then show MAC address table, very important. The switch runs MAC address table. So show MAC address, sorry. Show MAC address, sorry, MAC address, good. Address table. If I press this, now this is my MAC address table. That is the content of my MAC address table. And basically, there is nothing here. Now, when will your MAC address table begin to get populated? When the moment you begin to connect devices. So if I connect my system on this particular device, then the MAC address of my network interface card will be on the MAC address table of this router, on this particular switch. And so that will make movement of how do we put it, switching of frames from one port to the other very, very easy. All right, so basically those are the configurations, and this is what we have just done now. I've just shown you each of these particular commands. So I think show interfaces, we have done show interfaces. Okay, all right, troubleshooting network access layer. troubleshooting has to do with step-by-step way of trying to identify and solve a problem. Okay, and if you do show interface, for instance, you check whether is the interface up or not. If the interface is not up, you verify the cables. If the interface is up, how do you know whether the interface is up or not? If I just come, I say show interfaces, for instance, you see it will tell me fast Ethernet. Look at it. Fast Ethernet is down. It's down. Once it's down, then I need to actually plug in a cable there. All right. But if it is up, if it's down, I check those is up. Then are there indicators on the EMI? If yes, remove the sources. Verify the duplex setting is properly set on and things like that. Once you do that, is the problem solved? Yes, you are done. If it's no, document and escalate. So these are like steps you would go. All right, I think we will stop here today. Secure remote access. We have, even though we have done that, but we'll leave that for next class, which we are going to meet on Thursday. So it's nice having you guys on today's class. Let me see, is there any question on the chat group? Let me verify if there's any question. It's a minute.